पूछो जाके उनसे जिन पे रोशनी नहीं, पूछो जाके उनसे कैसी लगती है कमी.
Nikhil Shadab this side. So in today's session, you will get to know about corneal topography interpretation by Harshal Vanjara, sir. He has completed Bachelor's of Optometry from Lotus College and Master's of Optometry from ITM. He is consultant optometrist, contact lens and low vision specialist at Akshar Eye Clinic and many other places. Most welcome to the Optohub, sir. And I welcome all the participants to the Optohub. You guys can pen down your queries in the chat box, and if the session ends somehow, so please rejoin with the same link and please make sure to mute yourselves. Please, it's a request. Welcome to the Optohub, sir. Over to you now. Please continue.
Good evening. Thank you very much. So here we are today. We'll be understanding a little bit about the corneal topography. So before I start, I would like to tell that I would like if people get involved in I don't want this to be a one-way thing. So it would be great if people get involved and when I ask some questions, people can try to answer them, and we'll try to keep it as a more like a discussion, as compared to a lecture. So yes, corneal topography is a bit about topography. Topography is nothing but the surface analysis. Okay, it could be a geographical region, it could be any part of your body, or in this case, it is a cornea. Okay, so what we are trying to do is we are trying to assess the surface of the cornea, the interior most surface of the cornea. So that's why we call it a corneal topography. We all are aware what is a cornea. It is responsible for most of the refraction of the eye, and we are all aware about the anatomy of the cornea. I'm not going to go into the depth of that, definitely. And one thing we need to remember when we are talking about topography, epithelium is always bathed by precorneal tear film. So basically, the topography is mostly based upon the first Purkinje image. Okay, so in that case, the tear film plays a very important role in corneal topography. So the presence or absence or any kind of disruption of the tear film is going to affect your topography images, and it will give you a very different topographic outcomes. So we need to remember that a stable tear film is extremely important while performing a topography, and this should be the first things first. This is the first thing that we should understand about the topography. Right. So now, what do we do on the topographer? Okay, so first things first, we'll understand about an astigmatism. Again, we all are smart enough to understand what is astigmatism. It is nothing but the difference in the radius of curvature or in the dioptric values in two semi-meridians or in two prime meridians. And again, the astigmatism can be further divided in regular, irregular, with the rule, against the rule, oblique astigmatism, and there are a few more types. But we'll stick to a few of these for this session. So, how can a cornea be analyzed? What are the few things that you can analyze regarding a cornea? Okay, so first things first, what you can do is you can do a refractive analysis of the cornea. Second thing, what you can do is a geometric analysis of the cornea. So, what do we mean by refractive analysis? Refractive analysis is mostly, stuck to astigmatism part. How the cornea is refracting a light. Okay, because it is the first surface that refracts the light, so we need to have a very great idea about that. The second would be the geometry. What do I mean by geometry? Geometry means the measurements. How high is the cornea? How low is the cornea? Or how high and low are the different positions on the cornea? How much is the thickness of the cornea at different positions? And so on. So what do we observe? What do we measure on the cornea is refractive and the geometric analysis. What all equipment can we use to do all these analysis? Number one is the keratometer. Okay, so we all are aware what is a keratometer. It gives you the keratometry values of the central 3 mm, or else that measurements are different in different machines, but most common one is the central 3 millimeter. So what it gives you the steep axis, the flat axis, and the astigmatism. Second would be a corneal topography. So we'll come to what a corneal topography and the tomography shows us. And the last is an aberrometry. Aberrometry is again something related to refractive. It tries to tells us that how well is the cornea functioning, not in terms of diopters, not in terms of millimeters, but what is the quality of the image, how is the wavefront coming out, how is the wavefront acting when it reaches the cornea, right? So that is basically known as the aberrometry. So we won't be going in depth for about aberrometry or tomography or keratometry. We'll be today adherent to corneal topography in today's session. So what is topography? As I told you, it is the analysis of the surface. So this is basically based on the reflection. Okay. Next would be, what kind of principles does it follow? So it is basically based on Placido disk principle or else polar grid principle, and many more are there. But today we'll be sticking to Placido disk principles. Now, what are the applications of a corneal topography? So basically, first if we need to rule out any kind of presence of any kind of ectatic disorders, if there is an active treatment going on for some ulcer or for some corneal opacity or for any kind of surface disorders. So in order to monitor the progress of those conditions, we can use a topographer. The topographer is extensively used in contact lens fitting. So anyone who is practicing specialty contact lens, they know how good corneal topography and how useful it is in contact lens practice. I'm not saying that it's a compulsory to have a topographer at your place, but believe me, if you have a topographer at your place and you're a contact lens practitioner, wow, you're doing the best practice. The corneal topographer is also used for pre-cataract assessment. So in order to plan the incisions for the surgery, we use for that as well, and so on. And many a times you can find some subtle changes on the cornea which probably you might miss out on the slit lamp. Or if a patient comes to you and the anterior and the posterior poles appear to be normal, but yet the vision is not improving and the patient does not have a significant refractive error. So in such cases you might perform topography and you might see that there is some disruption on the cornea, or there is some subtle or early ectasia of the cornea. So, corneal topography in a nutshell has got a lot of applications, and we should not just limit it to those applications what I enlisted in the previous slide. It can be used for anything and everything basically. Next is a corneal tomographer. Corneal tomography, what is tomography? Tomography is a 3D analysis of the cornea. Okay, so the topography is only reflection based, that is only it analyzes the first Purkinje image. However, the corneal tomography is based on the projection. So it basically shines some slits on the cornea, it measures the thickness of the cornea, and then it gives you the analysis. Right, it gives you the elevation, it gives you the corneal thickness, and beyond cornea it also gives you lens thickness, anterior chamber depth, and so on. So we won't be much focusing on this in today's session. Okay, so the session would be mostly revolving around the corneal topographer, which is one of the best ones, that is a class 9000, which is from Carl Zeiss. And a little bit about the technical aspects of this machine is that it has got 22 concentric rings, okay, and it is infrared rings. These rings are all infrared, and it uses something known as a cone of focus technology. So what happens is, you don't need to have a very large bowl of the Placido disc. Instead, if you can see over here on the edge is this they have designed it in such a way that a very small diameter of the dome is enough to shine the light on the cornea and to provide an enough placido discs or enough kind of an image on the cornea, and which also helps to reduce the data loss and so on. So this is a patented technology. Okay, so as I told you that it is reflection based. Okay, so in this photograph, you can see there is a woman and a man standing in front of mirrors. Now let's assume that these mirrors are corneas. Okay, so this is a cornea, this is a cornea, and the woman and the man, both of them are placido discs. Let's assume that. So when the placido disc is shown on the cornea will act as a mirror and send some light back. Now the type of light, whatever it is sending back, this will be captured by the camera in the topographer, and then there will be some computer analysis and algorithms will be used, and it will give you the analysis. So basically you have to remember that this topographer is the cornea acts as a funny mirror like we see in the amusement parks. Okay, so what image you send, what light you are sending, and what you are receiving back, the difference between those, and the computer does the analysis and it gives you the results. So there are different maps of topography. When you see a topography report, you will see a lot of colorful round maps. Now we'll go in depth a little bit about all of them. That what do each of them mean and how they are different from one another. What is the meaning of those colors? Why there is a specific pattern for specific kind of astigmatism and so on. So there are 12 to 13 maps which we will be talking about today, and yeah, so let's go ahead with that. So the number one thing what we need to observe before you look at any maps, first you need to observe is the rings, the images of the rings. Okay, so on the left of your screen, what you can see is this is a very normal pattern what we observe of the ring coming. I mean, the ring which is emitted from the cornea, the reflection which is emitted from the cornea. Whereas on the other hand, if we see this, sorry, yes. So when we see the image on the right, so if you see these rings over here, these are close to each other as compared to the. I don't know why this is changing. I'm really sorry for that. Yeah. So over here, if you can see, the rings are pretty close to each other, especially in this area. On the other hand, if you can see, these rings are equidistant from each other. They are very much of a regular pattern. So you need to remember two things. Whenever you see such kind of a pattern, that means the cornea is probably normal and regular. When you see that these rings are close to each other, that means that that region on the cornea is steep in nature. And if you see that the rings are far from each other, that means that the cornea is flat in nature. Okay, so this will, the rings images itself will give you, a little bit of idea about what kind of a cornea you are dealing with. So if you see any such patterns in this, so you understand, all right, this patient has got a steep cornea, probably ectasia or probably something else. And if you see that the rings are far from each other, you might start thinking, okay, this is a flat cornea. Maybe the patient is an ortho K lens user. Maybe the patient has undergone LASIK, and so on. Right. So this, your active thinking starts from here itself. Next, what we see is the color shapes what we observe. Okay, so we'll talk about the shapes what we see on axial and a tangential maps, or in other words, they are known as refractive maps. Okay, so sorry. So what we see is a dumbbell basically. First things first, I'll talk about what we see is a dumbbell or a bow tie. So in this case, what you see on the left is a dumbbell, is an actual dumbbell. And on the right side, what you see is an hourglass. On the center, what you see is a actual topography report. So this is something known as a dumbbell or a vertical bow tie, and so on. So these are a few terms that we use when we are looking at the topography reports. So whenever someone says there is a vertical dumbbell or a horizontal dumbbell, you understand what they are talking about. Now, why does it have a dip in the center? Why is it shaped like this? Why is it shaped like an eight? See, the actual cornea is not like this, but because there is a camera in the center, that area is not analyzed. That area does not emit any rings on the cornea. So that's why this is an area that is not captured. Hence, it gives us a shape of an eight. Ideally, it should be just an oval. Right, so this is something known as a dumbbell, and here are a few shapes what we observe on corneal topography, especially on the refractive maps. The first one is a round shape. This might be observed in very low, in cases with low astigmatism, or you might see such a pattern in a nipple shaped keratoconus. And the next would be an oval shape. Again, it's seen in low astigmates. We rarely see such patterns due to the limitations of the machine. As I told you, there is a camera in the center. Next is the superior steep pattern. The next is a inferior steep pattern. Now what does these mean? That superior steep simply means that the superior region of the cornea is steep in nature, and the next one means that the cornea is steep in inferiorly, so inferior steep pattern, it's not very well defined like this, as it is shown in the pictures, but it might extend more towards the periphery and so on. Next is an irregular pattern. This kind of a pattern again you might see in cases with very low astigmatism, or else you might see in cases whose tear film is not steady, or else you might see such irregular patterns in which the patient has undergone some sort of keratoplasty, or there is a trauma and so on. So this is not classified anywhere. So whenever you see such patterns, it's an irregular pattern. But yeah, you have to remember one thing, that whatever pattern you observe, you have to correlate it clinically. Okay. Next is a symmetric bow tie. Okay, now let's talk about this symmetric bow tie. As you can see, these two vertical ovals, they're joined over here, and both the ovals have got the same size. That means it is known as a symmetric bow tie. On the number 8, what you are seeing is an asymmetric bow tie, and IS stand for the inferior steep pattern. So this is an asymmetric bow tie. Inferior region is steep as compared to the superior region. So such kind of patterns you might see in early cases of keratoconus or advanced cases as well. But yeah, we'll come to that at the later part in this session. Next is the asymmetrical bow tie and superior steep pattern. You see such patterns probably in Terrien's dystrophy, or else you might see it in Terrien's degeneration, not dystrophy, sorry. You might see it in Moorens ulcer, or you might see in some marginal ulcer and so on, which are superior in nature. Next would be asymmetric bow tie and SRAX. Over here you can see symmetric bow tie SRAX. Now what does this SRAX mean? It is nothing but skewing of radial axis. Now as I told you that there are two ovals that we are observing. Okay, so the oval number 1 and oval number 2, what we do is we measure the angle between the two. So the oval number 1, which is vertical, we draw a line through it and through this meeting point, and we take it ahead, and then we draw another line from the center of the skewed bow part of the bow tie, and then we draw another line over here, and the angle between these two, that will be your amount of skewing. Okay, now when is this kind of measurement of such axis is important? When you are suspecting a case with some sort of ectasia, right? So you start observing that there is a skewing of axis. It becomes more significant when it crosses 21 degrees, in measurement. So whenever you see that, okay, that there is uh, skewing of axis of more than 21 degrees, you start suspecting for keratoconus or maybe some other ectatic disorders. So again, this can be symmetric in nature or asymmetric in nature. In this case, what we are looking at is asymmetric bow tie, which is skewing of axis is there, and it is a inferior steep pattern. Right. Are we taking questions in middle or only in the end? Hello.
Yes, sir.
Are we taking questions in the middle or only in the end?
So it's good to take in the end, or if you want, you can take in the middle.
Yeah, I mean, we can just ask if anyone has got any doubt over here, so you can.
So the students will write their questions in the chat box, and at the end, we will be discussing the questions.
All right, great. Then I'll start moving further then. Right.
Yeah. Okay, sir.
All right, great. Okay, so we'll talk a little bit about the color scale. Now, as I was telling you, there are so many colors in this, and what do these colors mean? First things first, we have to remember the most important thing is that warm colors stand for steep cornea or steeper regions on the cornea and elevated regions. Okay, so steep in whenever you're looking at any refractive maps, that is the tangential map or axial map. So in such cases, you whenever you see the shades are towards warm, so it means that the cornea is steep in that region. And whenever you see any cooler shades, that means the cornea is flatter in nature, or it is depressed over there. You know, there can be elevation or the depression. Elevation means warm colors, depression means cool colors. Steep means warm colors, and flat means cool colors. Okay, so it's very simple. But when we see over here, all the topographer machines have got their own scales. Okay, so there are basically three scales. One is something known as an absolute scale. Second is something known as a normalized, and third is something known as a custom scale. Right. So what all these terms mean, we will talk about that now. So what is an absolute or a standard scale? It means that there are a specific number of colors over here on the right. If you can see, there will be a specific number of colors over there mentioned, and each color will stand for some dioptric value, and it will have some sensitivity. Okay, so let's say there is one square, the last one on the right side, what you can see over here, it is standing for 32, and then above that, that will be 33, and then it will be 34. So how do we determine that? So over here one diopter is mentioned. So in a standard scale, it will just follow one specific pattern, regardless of how steep or how flat your cornea is. So in this scale, it is a standard scale. So this might look identical to 34 on the right. Okay, so this is something known as an absolute or a standard scale. You can use this kind of a scale when you are, when you want to compare a patient's topography reports on two different machines. Okay, so what you can do is you can choose a standard scale on both the machines, and then you can take a report, and then you can compare, because it is a standard scale. So the same kind of patterns will be visible. So comparison will get very easier. Next one is something known as a normalized or an auto or an adaptive scale. Okay, these are a few different names. Okay, let's say again. On the left, what you can see is 39.75 diopters. This is the flattest area on this cornea. And on the most right side, what you can see is 45.25 diopters. So this is the steepest region on this cornea. So now this auto scale is very smart. So what it will do is it will calibrate its number of shades and the step points accordingly. Because the flattest one is 39.75, so it will have its coolest color noted as 39.75, and because 45.25 is the steepest area on the cornea, doesn't matter on which region it is because 45.25 is the steepest, so the auto scale will have its hottest color as 45.25. So any points between these between this range will be given an exclusive color. Okay, so in this case, and it has got an increment of 0.25 diopters. So now what is happening is there is a 39.75 point, a point with 39.75 diopters, and the next point has an increment of 0.25. So over here it is 40 diopters. So now it will give an exclusive different color to 39.75, as well as an exclusive color to 40 diopters, and then so on. So it will be highly sensitive. Now what this kind of a scale will do is this will magnify the defects on the cornea. It will help you to detect any subtle changes on the cornea. Okay, now I'll show you a practical example of the same. What difference is it making? So on the left, this is, let me tell you, this is a pattern of post LASIK. Okay, this patient had myopia, and the patient has undergone LASIK, and hence there is a flattening over here. We'll see more patterns, and we'll see more interpretation in the upcoming slides. But on the left, what you can see is this is an auto scale. Okay, auto scale, what auto scale does is it has got a specific minimum value, and it has got a specific maximum value, and it has got a specific step height. Okay, this step height again you can change if you want, but in auto scale, if you choose auto scale, it will be calibrated according to this cornea. Okay, so on the left side, what you are seeing is auto scale, and over here, what you can see, it is 38.50, and the steepest is 44.00. So that means that this patient's cornea has got a flattest region somewhere on the cornea of 38.50, and the steepest region on the whole cornea is 44 diopters. So it does not have any unnecessary, data points or unnecessary shades. So it utilizes all the shades to give some color on the cornea, right? So over here, if you can see, auto scale is giving a very basic pattern. Now let's have a look at this on the right side. So over here, it's a standard scale. Okay, and over here, what you're seeing is 38.5. Okay, that is fair enough. But if you see the steepest region is 49.50. So now what it is doing is it is magnifying all your flatter regions, but it is unable to show you the warm colors of the steep regions. If you just look at this pattern, nobody would say that there is a little bit of steep region over here, whereas on the left side on the auto scale you understand that there are subtle steep regions as well. Another thing is that this is increasing in zero point 0.5 diopters of height in step, zero point 0.5 diopter step. On the left side, you see it's in 0.25 steps. So the 0.25 steps is going to give you more detail about the cornea as compared to the zero point 0.5 scale. Although it has got a longer range, but this longer range is useless because this patient does not have a steepest K of 49.5. So regardless of the cornea, it doesn't matter how steep the cornea is or how flat the cornea is, it will still use this scale only. So let's start about interpretation of the different maps. So the first one is something known as an axial map. This is the most common map which is used, and this is the easiest one to predict or easiest one to interpret. However, this is not the best map when you are looking out for some subtle changes. So what this does is the drawback of this map is that it assumes that the cornea is a spherical surface, which is very much untrue because our cornea is an
Hello, sir.
aspherical. Different is what? It's a bundle of rays that travel at the same time, and they reach at some distance at a given point of time. Okay, so wavefront, it's like uh, it's like an team of soldiers. When the soldiers are moving, they move in a single line, just a single line of those soldiers. So that is something, the soldiers and the wavefront is the same. That means that all the packets of light which are over there, they are going to travel in the same direction at the same time, and they will cover the same distance. Okay, so that is something known as a wavefront. So what does wavefront tells us? Wavefront tells us about the aberrations. Okay, so that means a reference wavefront, that is an ideal wavefront, is compared with the wavefront which is coming from the patient's cornea, and the difference between the two is measured. So that will give the difference between the two is measured, and whatever the impurities are there, or whatever the differences are there between the two, they are considered as impurities or aberrations. So this basically tells you the wavefront or the aberrations which are present on the anterior surface of the cornea. Now one should be reminded that this wavefront is not a true wavefront, but it is based on the Placido disk images. So there are some complex mathematical expressions which are being used, and then it is displayed. We should remember that it is not affected by accommodation when we are using a topographer. Ideally, the wavefront is affected by accommodation because when accommodation takes place, the refraction of the light changes drastically. Okay, so this will not be affected by accommodation because it's just the first Purkinje image which is analyzed. It will tell you about the lower order as well as the higher order aberrations. But one should remember that in this case, lower order aberration do not mean the refractive error. Lower order aberrations only mean astigmatism in this case. Whereas in true senses, the lower order aberrations are your refractive correction, that is the spherical as well as the cylinder. But this one will not tell you the spherical correction because it's not emitting rays up to the retina. It's only measuring the first Purkinje image. It gives you it can give you the analysis in a map form, or else it can give you analysis in a Zernike polynomial form. So basically it tells you which all aberrations are there in the cornea, in this specific anterior surface of the cornea, and how much of that aberration is present. For example, the trefoil or the comma or defocus or oblique astigmatism with the rule, against the rule, and so on. Right. So we won't go much in depth about what are aberrations and everything. But yes, one should remember a couple of things that whenever you are seeing cornea which have undergone LASIK, or for myopia or for hypermetropia, or if any of these cornea have keratoconus, so in such cases they will have specific patterns. So one should remember that whenever a patient has undergone myopic LASIK, okay, whenever a patient has undergone myopic or a hyperopic LASIK, you will see more of a defocus and you will see more of a spherical aberration. Whereas on the other hand, if the patient has got keratoconus, these kind of patients will have more of a vertical coma. Okay, so that's how it is. These are a few things that you can always look out for. And if a patient has undergone, RK in the past, then the patient will have a lot of quadrifoil or oblique quadrifoil and so on, and as well as spherical aberrations, and as well as with the rule or against the rule, secondary astigmatism. So there are specific patterns what you observe in specific cases, but it wouldn't have much of indication in the practices. But yes, one should remember that these kind of patterns will tell you or give you an idea that the patient has got some genuine problems which are arising from the anterior surface of the cornea. Right. So that's how it is. These are a few maps of the aberrations. This is not how it basically looks. These are all bifurcated maps of the aberrations. The whatever you maps you see, these are all combined forms of few of these aberrations, or whatever aberrations the cornea has. Now this is something known as image simulation. The next map on cornea on corneal topographer, what we see. Image simulation is nothing but hypothetically tells you that what kind of a vision the patient will have only and only due to the anterior surface of the cornea. Okay, so in this case, if you see, there is a logmar chart over here and it is pretty much blur. If you can see, there are ghost images. Okay, and next is a PSF, point spread function. Now the name only suggests what is it. So suppose if point object is shown to an eye, an ideal optical system will form a point image. Okay, but as we know, eye does not have a perfect optical system. So what it will do is, so whenever there is a point object, it will not form a point image on the retina. Whereas rather than having a point image on the retina, it will have a spreaded, or it will have a spread point formed on the retina. So that means if you can see the pattern over here, it is pretty much spread. It's not a point, it is spread function. So point spread function tells you that how much a point object will form a point image which is spread on the retina, that way. Right. So, and the next is a MTF, modulation transfer function. So whatever cornea you are measuring, so how much amount of light or how much contrast it is letting pass through itself. This is a measurement of that. Modulation transfer function. So whenever there is a low modulation transfer function, that means the contrast of the vision is going to be less. And whenever there is high MTF, there is high modulation transfer function, means the contrast is fair enough or it is good. Over here, as you can see, it is less spread, it is more in the center. That means it's a good modulation transfer function. So one should remember that modulation transfer function and PSF are inversely proportional to each other. Okay, now over here is, as you can see, this is a ideal system, ideal optical system. Over here, the point spread function will be less. Okay, so it's a very small and very thin, building of it. Whereas MTF is very spread. Okay, that means more of the contrast is getting passed through this specific cornea or specific optical system. Second one, if you can see here they have got some vertical comma over here. So the PSF, if you can see, this PF is not a thin line in the center, but it is spread. Whereas on the other hand, if you can see, the modulation transfer function has shrunk. On the third one, what you can see, the PSF has spread a lot and the MTF has shrunk a lot.
That means whenever there is more PSF, that means the light is getting more spread on the retina. It's not reaching a pinpoint location. And more the spread of the light of any object, less will be the contrast which is reaching on the fovea namely. I'll show you an actual case over here. So this is a normal case. So this is a patient who has undergone myopic LASIK. So on the right side, if you can see, this is the point spread function. A little bit of spread is observed, and if you can see that there is a fair amount of MTF. Now this same patient has got ectasia on the in the other eye, post LASIK ectasia. So on the right side, you are seeing a PSF. It is extremely spread and giving you a very haywire pattern. Whereas on the other hand, if you can see MTF is hardly one single, very thin stick. Okay, so that means there is a very less modulation or very less contrast that is being transferred from the environment to the retina due to the anterior surface of the cornea, and there is a lot of spread of the light when it is reaching. So one should remember that these are inversely proportional to each other. So we should remember that in normal cases, the MTF will be wide and the PSF will be shrunk. And on the other hand, if there is an irregular cornea or imperfect optics, that means the modulation transfer will shrink, and the PSF will be much spread out. Right. So next one is Pathfinder. Pathfinder is nothing but artificial intelligence that tells you that this cornea may be normal, or this cornea may be having keratoconus, or this specific cornea has undergone the myopic laser vision correction, hyperopic laser vision correction, or some other patterns. So as I told you previously, the mean curvature has got the CIM, TKM, and shape factor. All these values are used in Pathfinder 2, and then all these parameters are measured from the normal cases. All these parameters are measured from known cases of keratoconus. All these parameters are measured from known cases who have undergone myopic laser vision correction. All these parameters are measured from the cases who have undergone hyperopic laser vision correction, and then all this data is fed into the database of the machine. And whenever you capture an image of the patient's cornea or take the topography of your patient's cornea, it will compare the data from your patient to the database, and it will tell you that how much percentage it is matching with the database of that specific condition. Right. So as I told you, it compares the 12 parameters. That those are all the parameters that we get from the mean curvature. It can be confusing at times. I'll come to that why it can be confusing at the later phase. In this case, we can see a normal case. So as you can see over here, the CIM is in the yellow region, the TKM is in green region, and the shape factor as well as is in the green region. Okay, and the pathfinder, as you can see over here, the axial curvature, it does not show any steepening. It is falling in the normal area in the mid region. It's not too steep, not too flat. We are not seeing too many warm, or we are not seeing too many cold colors, and we are just seeing the normal the colors. As well as on the mean curvature, we are not seeing any abnormalities over here. Hence it has been stated as 83% normal. So there are 83% chances that this cornea is normal. This is what the pathfinder wants to say. Now this is with the rule astigmatism, as we had already seen. I'm just trying to show you a case. So in this case, how to interpret a cornea topography report. The first things first, what you have a look at is the what kind of palette and the scale is being used, what kind of step size is being used, and then you go to the pattern. So this is a this is a vertical dumbbell, and it's a symmetrical dumbbell or symmetrical bow tie. Okay, and on the right side you can see the measurements in the different rings, as well as you can see the q value, that is minus 0.34. Now most of the things are falling into the normal ranges. This is against the rule. Against the rule, it means the steep meridian is on the horizontal axis. That means your flat meridian is the vertical meridian. That means against the rule, astigmatism patients who will have in a minor cylinder form will have an axis at 90 degrees. So whenever you see cases who have got refractive error and their astigmatism is in 90 degrees, so in such cases you will see this kind of a pattern, which is known as an against the rule astigmatism and a horizontal dumbbell or a horizontal bow tie. The next would be an oblique astigmatism. Oblique is nothing but the ones which is not vertical and ones which is not horizontal, that will fall into the oblique astigmatism. This is how oblique astigmatism looks like. Now, when do we suspect for keratoconus? Now, topographer, as I told you, is widely used for diagnosing ectatic disorders. So, number one is the rings images when we see that they are irregular. Secondly, the steepest keratometry is more than 47.2 diopters all around the cornea. It's not just in the central 3 millimeters, but around the cornea. Superior inferior difference is of more than 1.5 diopters when it is inferior steep pattern. Okay, when the same thing we were seeing in the mean curvature map. Skewing of axis SRAX, what I showed you in the initial one of the initial slides. If it is more than 22 degrees, you should start suspecting such a case for keratoconus. And there is an apex displacement inferiorly. So in the mean curvature, again, when we had a look, the mean steepest mean curvature, where the position of that specific point, this is what we mean by that. And the q value of more than -1, but q value may not be more than -1 in many cases of keratoconus. So this can be an optional parameter, but when you are dealing with cornea report, the tomography reports, so in such cases q value more than 1 becomes significant. Okay. And the CCT of less than 470 microns, definitely we cannot measure the CCT. There is a central corneal thickness on the topographer. So in such cases, you might have to use a pachymeter or some other equipment. Right, so here is a case of keratoconus. This is, when we look at the axial curvature. So first we look that they are using an auto scale, and it's a 0.5 step what they are using. The steepest is 50.5, flattest is 38.25. The rings images, as you can see over here, the rings are pretty close to each other. That means this is a steep region. On the tangential, if we can see now over here, if you're seeing, this is a very smooth and beautiful pattern. But on the other hand, on the tangential curvature, over here there is red region, whereas over here there is only green region. This means that there are steep regions present over here which are not being measured or not being displayed correctly due to the axial curvature measurement. So in such cases, you need to have a look at the tangential curvature where you can get subtle changes as well. And if you look at the pathfinder, it is telling that 74% chances are there that this patient has got keratoconus. Now, in such a case, you go for, you go and measure the central corneal thickness. You perform a you perform a corneal tomography. So you will understand that even the posterior surface is going to be elevated because the keratoconus arises from the posterior surface. One should remember that. So it will manifest more on the posterior surface as compared to the anterior surface. And one more parameter what we are seeing is q value. So the q value is almost -1. Over here it is -0.91. So it is almost approaching -1. So that means there are a lot of things that are indicating towards keratoconus. Over here again, if you can see, this is a asymmetrical bow tie which is got an inferior steep pattern. Over here inferior steep pattern, and there is a skewing of axis over here. If you can see, both the circles are actually fused in this case, whereas in axial curvature, if you see, you can see those two circles. There is inferior steep and superior flat. So what we do is we draw a hypothetical line from here and another from here, and the difference and the angle between the two will be measured. I'm sure it's more than 22 degrees. Unfortunately, I couldn't draw the diagram here, but that's how it is. So this is how you come to a conclusion that this patient has got some ectasia, and this may be a keratoconus, and you should confirm your diagnosis based on the clinical evaluation as well. Now there are conditions which can confuse us, that is the keratoconus and the PMD. Okay, now what happens is keratoconus. In keratoconus, you will see inferior steep pattern, whereas on the other hand, the PMD in PMD you will see that there is a crab claw pattern, or else this is something also known as a kissing dove patterns. So or the kissing birds. Okay, so we consider these two as birds and they are kissing each other, or else a crab claw. It looks like a claw of a crab. Okay, in this there is a very localized area of thinning in keratoconus, whereas on the PMD there is a huge area of thinning. Okay, and one more thing that can help us to determine or help us to distinguish between the two is that the PMD patients will have against the rule astigmatism, whereas on the other hand keratoconus can have any type of astigmatism. Right, so this is the basic difference between the two. Again, this is another case of clinically diagnosed keratoconus. So first we look at the axial curvature map. So it's an inferior steep pattern. There is no skewing of axis, but it's a inferior steep pattern over here. And if you can see over here, the steep K is more than 47.2. It's 51.54. So that means this is a definitely steep cornea. In the mean curvature as well, you see there is a huge area which is giving a lot of steepness. And if you can see over here on the right as well, the maximum mean curvature is flagged as red, the mean is flagged as red, mean all these three means are flagged as red. That means this patient has got a pretty steep cornea. And when you come to the left, all these readings, the CIM, TKM and the shape factor are falling in the red region. So this is a big flag towards keratoconus pattern. Now let's have a look at the myopic LVC. This patient has undergone myopic laser vision correction. Patient had myopia preoperatively. Let's have a look at the axial curvature map. So the central region is pretty flat. As we know that the central region is made flat by ablation, and the mid periphery and the periphery regions are steeper as compared to the central region, especially the mid peripheral region. Mean curvature, on the mean curvature map, if you can see over here, there is not much of normal area, whereas it's a little bit on the cooler side. That means this area is flatter and this area is little bit steeper. Whereas on the other hand, if you look at the CIM, TKM and shape factor, they're all, the TKM and shape factor are falling in the red regions. But that does not mean that this cornea is irregular or abnormal. It just definitely means that yeah, the cornea is an oblate shaped cornea, because TKM, if you see, it's 39 diopters. 39 diopters is abnormally flat actually, but we make it such flat when a patient is undergoing myopic laser vision correction, and hence the Pathfinder 2 software is also showing myopic LVC. This is again, this is just a difference map that we see on the topographer. This is, the tangential curvature. It's measuring the preoperative and the postoperative. So it will tell you that how much the cornea is flattened and how much the cornea is steepened as compared to the initial examination. So on the left upper side, what you are seeing is the preoperative cornea of the patient. In the central regions, you can see a lot of red regions, and on the lower one you can see a lot of blue region in the center and red colors in the mid periphery. That means the cornea has become flatter in the center and steeper in the mid periphery. It does not mean that the mid periphery cornea has become steeper, but the central cornea is flatter as compared to the mid periphery. And this on the right side, it will show you the difference between the two. So it subtracts the previous and the current report and it tells you what is the difference. So the cooler color means there is a depression or else there is a reduction in the dioptric values. Red color means there is an increment in the increment or steepening in the dioptric values. Again, another case of myopic LVC, myopic laser vision correction. Now in this case, if you can see, this blue region is pretty much not in the center and it is displayed elsewhere, displaced elsewhere. So this means that either the flap was not being able to take proper, I mean, the surgeon could not take the flap properly, or maybe the patient move the eye during the ablation of the tissue and so on. So this is a displaced flap, or else maybe the surgery was performed with a topo guided technology. That means it analyzes the position of the pupil, and then it does the ablation based on the position of the pupil and the position of the visual axis. So this ablation maybe is done around the visual axis. Maybe the visual axis and the pupillary axis is not at the same place. So we'll not go much into depth of that, but yeah, this can be a useful tool to analyze any displaced flaps or displaced ablated areas and so on. Right. Again, it is flagging it as myopic LVC. Next, okay, now since we don't have a question and answer session, so yeah, so this is a case of hyperopic LVC. If you can see, the central area is steep and the mid periphery area is flatter, right? So this is what is done is the laser ablation is done in the mid peripheral region. So the central area appears to be steep as compared to the mid periphery region. This is totally opposite to myopic laser vision correction. Okay, similar pattern we'll see in the mean curvature, that the central area is steeper as compared to the mid periphery and the periphery. The CIM is in the green region, whereas the TKM, if you see, it's 50.9 diopters. Now one of these uh, parameters is fulfilling the criteria for keratoconus, but that does not mean the patient has got keratoconus, right? Because if you see over here, the maximum mean curvature x and y axis, it is not displayed, it is not displaced elsewhere, it is in the green region. So that means this patient has undergone hyperopic LVC, and definitely there is a history taking which comes into play, and as well as your clinical evaluation. So that's how it helps you to determine, to distinguish between hyperopic LVC and a keratoconus. And whereas on the other hand, this will never show you any asymmetrical bow tie or something, the hyperopic LVC. Whereas on the other hand, keratoconus will show you asymmetrical bow tie or dumbbell. And this is a post
So,
keratoplasty. The axial curvature is, yes,
so how many slides are left?
a couple of those.
Okay, so actually most of our participants are not there. There were 64 and
Mhm.
now only 26.
It's
So
okay.
can we just
Mhm.
schedule a part 2 session?
I think we are done. We just have a couple of more slides and then we are done.
Because the session is about to end within 5 minutes.
Yeah, I think we'll be done by that. We can
Okay,
just
okay,
take
okay
questions
then.
after this. Yeah.
Okay
Right.
then.
So this is a post keratoplasty, basically cornea, and you don't see any specific patterns in that, and that's why it will show you in others. So there are no specific values in CIM, TKM, or shape factors in such case. And as I was telling you initially that the tear film is an important factor to be taken into consideration. So in this, the pathfinder will show you KCN pattern, but this patient does not have a keratoconus. It is just irregular tear film, which is mimicking as a keratoconus. So in such cases, you do not follow the pathfinder. And what are the collateral uses of corneal topographer? It can help us to get lenticular opacities because it uses retroillumination. Size of the pupil can be measured. Alignment of the toric IOL, again, it is by the retroillumination, and detection of PCO, if any. Right, so this concludes today's session. For the topography, we can have questions now. If anyone has got any, I would like to thank you very much for having me here. Right, so
Thank you so
if
much,
anyone
sir.
has any
It
questions, we
was a
can take the
very
questions now.
informative session, very informative, very knowledgeable. Thank you so much. And yes, we are having questions.